Okay, good morning. We're going to start on the columns for the Vickie project, and you can see there I've got a big piece of brass there sitting on the compound, and that's the only piece of brass I've got that's large enough to make the largest column. So it's only enough to make one, so I don't want to make a mistake. Anyway, what I'm doing in the lathe now is just truing up a piece of aluminum that we're going to take a test drive on, and we're going to build the large column out of that piece of aluminum. If it works out okay, then we'll go to the piece of brass. We do have brass to make the two small columns, so we have an ample amount of that in the shop, so no problem. Brass is getting pretty expensive these days, so anyway, what I'm going to do now is I've trued up between centers just a piece of brass. It's about 1.25 inches, and I think I need about a little over 1 inch to make the large column, so I'll probably take it down a little bit more before I change the rear center, the center and the tailstock. We're going to have to offset that center, so I've got something to do that with. I'm going to offset that center and cut the there's a 3-degree bevel on that thing, so we're going to cut that first. At least we're going to get started on it. And we might not cut it down to size, but see if I can put the camera here on the column so you can see it, what we're going to do. I've got the plan here. Let me see here if I can do this. I'm going to zoom in on it. It's kind of crooked. I suppose I could move it over here someplace else. Let's see here. Maybe that's a better place. Let's see here. Let me move it over there. Maybe it's not quite so crooked. Anyway, there's the columns. We got one large column and two small columns. Anybody that's doing this project, I will tell you that these drawings aren't perfect, so this is going to be somewhat of a seat of my pants deal. The heights of the columns seem to be correct, the dimensions, but the rest of it is just stuff. And so I'm going to keep it's got a 3-degree bevel on it. I'm going to keep that and try to keep the dimensions for top and bottom. There's a lot of dimensions on the large column, but the small column is lacking. So, but basically, what's happened there is they've scaled it down to the right scale factor to get the correct height for that. So that's what's happened. He doesn't say so in the instructions, but that's basically what's happened there. So I'm going to basically do the same thing. Even though he scaled it down, he calls out some of the dimensions to be the same, which that's impossible. So there's a lot of strange things going on here. But anyway, we're going to do the best we can to keep it looking like it's supposed to look. And so that's where we're at. So I'm going to break the lathe down now and set the offset up so I can cut the 3-degree bevel. And I'm only going to use about 3 inches of that piece of aluminum. That's 6 inches long. So eventually I'll cut that down to size and put it in the 4-jaw chuck to do some of the additional work. But right now it needs to be between centers to put the bevel on it and some of the other work. So with that, I'll bring you back. Okay, I'll break in here just for a second. This is a setup to cut the bevel or the angle on this column. So it's got to be 3 degrees, which is actually pretty radical compared to like a Morris taper or something. So it's pretty radical. I've got 2 indicators set up. I got a 2-inch indicator on the carriage and a 1-inch indicator on the cross slide. And we just keep working them back and forth, maybe 10 or 15 tries till we get them balanced. So we know that in 2 inches, which is my indicator on the carriage, we know that in that distance the travel is 105 thousandths, I think. So I got a couple marks on the workpiece. I got a stop set up for the left-hand side of the bevel. So let me move it. You can see it happen. I'm going to move it over here. I move this to 0. Actually, it's not right now, but it's touchy business. And then I'll move this over 2 inches, watching the other indicator. And back to 0. That's 2 inches right there. And it should say 105 thousandths right there. It says about 106. Pretty close. It's really hard to get it perfect, but you can get it within a thousandth or half a thousandth in 2 inches. That's usually what I use. And then as a double check, normally what I'll do is I'll put I have just a three degree, what do you call it? Anyway, got 3 degree measure here, and I just put it on there and eyeball it to make sure we're at 3 degrees. And this is not, we're not making pianos here, but we do try to get it in there. Let me move the camera just a little bit. You can see my offset tool. There's a video on that, and this offset tool works really, really well. So let me move the camera a little bit here, see if I can get on it, but I don't think I can get the camera close enough to look at it. Well, there it is. All it is there's a dovetail in here, and this piece slides back and forth, and this is a very tight fit over the quill here, and a couple set screws. All these set screws have nylon ends, so they don't damage anything. And hopefully you can see that in the camera. I don't know. Probably can't zoom in on it anymore. That gives you an idea, anyway, what it looks like. So now we're gonna cut this bevel on here roughly, and we'll go from there. I'll bring you back. Okay. I'll bring you back later when I figure out the diameters and we start cutting the internal properties. And I get these diameters set up for the square portion at each end, which is, at the big end, it's about 1 inch diameter. At the small end, I can't remember exactly what it is. The big end is about He's a couple 100,000 large right now, so we're going to have to take this down some more. So with that, I'll bring you back. Okay, I thought I'd put this little clip in here. So we got the bevel, the beveled portion, or the tapered portion, whatever you want to call it, down to some workable size. So I've used about 3 inches of this piece of rod. Probably didn't need to use that much, but eventually I've got to chuck some of this up in a 4-jaw chuck to work on the mill. So the next thing is I've taken the drawing, and like I told you before, I have a drawing. See if I can hold this up here. See, I have a drawing there with a bunch of dimensions on it. Okay, I'm not going to go over all that now, but I have a dimension for the width at the top and bottom of the taper, and that taper is inset, right? So that's the first thing I've got to cut. After I get that cut with the little radiuses at the end, then I can actually get rid of this setup and put it back to a normal setup between centers. So right now I have to leave it set up this way and till I finish this inset. So that's what I'm doing now. I'm just going to throw a little bit in here, and we're going to just, get to the right depth. My taper is perfect because I did mark it off. You probably can see the marks on it there where I've marked it off. So I know that the taper is right, and I got the right diameters at each end of it to cut the square base out of. So anyway, with that, I'm just going to keep going here. Let me zoom in on a little bit. I've taken a parting tool and widened out a groove. It's not actually deep enough right now, but that gives me room to get my cutter in there, and I'm just using a pointed insert there to whittle it away. Eventually I'm going to have to go to a different type of cutter, but anyway, this is the most difficult part. Once I get this done, I think we're in good shape. So I'll just zoom back out a little bit, and I'll put a few minutes of this on video. So anyway, with that, let's get going here. And I'm just taking, about 20 thousandths off the diameter, and I'm using a little bit of WD-40 on there. I don't have a stop set up. I'm just sitting here working on it. This insert seems to be working pretty nice. I've only taken this out of the lathe, I think once. I re-greased the end, and I tried to get it set up so it's loose enough that it doesn't get too hot, and it's tight enough that it doesn't move around between the centers. So I don't know if those grooves at each end are wide enough, but right now, that's for what I'm doing, they're fine. Eventually, I'm going to have to widen those grooves out a little bit more. This is the area where this large column gets 12 flutes around the 360-degree diameter. So that'll happen on the mill. And these two areas that got marked off on each end. This is the total length of it right here, this final mark. And those two ends will become square. So I'll mill them square after I get it on the rotary table. So. Hopefully we can get most of the material off here this way. Eventually we'll have to do something else to finish it up. At some point here I'm going to have to make the grooves a little wider. Okay, I think I'm going to make the grooves wider. I'll stop the camera now. I just wanted to, I'll bring you back on the next phase of this. But I just wanted to throw this little tidbit in to show you how I'm going to do this large inset area here. And so with that, I'll shut the camera off and I'll bring you back later. Okay, one more quick look here, and I'm going to stop for the day. But we've used the triangular tool here to get down as far as we can, and also we used a different tool bit to take the inside corners down to the exact dimension that we need. So they need to have a 30-second radius down in there. So I just used this tool bit that I used on the cylinders and went down in there and got the ends cleaned up and down to the correct depth. So now we need to clean a little bit more out of this area here. So we've done all we can with this tool bit. So we're going to go to our grooving bit and just clean the rest of that out of there. So we've got a grooving insert here that we're going to use to clean the rest of that out of there. I might be able to do it with this homemade one that I made. That's possible. I may give that a whirl and see how that cleans it up. But anyway, with that, I'll shut the camera off now, and I'll bring you back just before we move this to the mill. I've got a couple. I got a boss that goes here and here, and then the square areas left. Those are little tiny grooves in there, so they only take a few minutes, and I'll lay those out and do those. So with that, I'll shut the camera and bring you back later. Thank you. Okay, we're squaring up the top and bottom of the column, and I've made a little drawing here so you can see that. So I just calculated how much we got to cut off the existing diameter in order to get the dimension we want, which in this case is 715, I think, 0.715, 715 thousandths. So that's what we're doing now. We cut the large one, worked out okay. We've had a couple little mishaps along the way, but nothing exciting. So the test drive has been beneficial because we have discovered a few things. So it's been a good thing to do. Anyway, I'll continue on here. We're just gonna square up the small end, which is we want to get it down to 562.562. So we got to go 123 thousandths down, and I've already set up the DRO on the Z, so we're going to dial in 123 thousandths. Since it's sticking out a long ways, I'm just going to take small cuts here and work my way down. So with that, let's get going. We're taking off just 30 thousandths at a whack here. Okay, there should be. Well, we squared up the two ends, and so now what we're going to do is we're going to get that we're going to get the end mill centered up on the tapered portion, and we're going to cut the flutes. We got 12 flutes to cut with a 3/32 inch ball nose end mill. So that'll be the next step. So I'll bring you back once I get set up, and we got to raise the sign vise 3 degrees to do this. So right now we're sitting on a sign vise. I don't know if you can see that or not, but right now we're sitting on a sign vise down there. So we're going to raise that up 3 degrees, which is I think the height is 206 thousandths. So we'll get some gauge blocks and raise that sign vise up 3 degrees and get ready to cut the flutes. So that'll be the next step. Then this 4-jaw will come off the rotary table, go back on the lathe, and we'll we'll part it off, we'll finish off the ends and whatever else we need to do, maybe a little polish work on it. So, and that'll complete the column. Hopefully all that'll go well and we'll be able to proceed with the brass columns next. Anyway, with that, I'll bring you back. Okay, I put 206 thousandths under the sign vise. Technically that's supposed to be correct. I noticed that I'm running up and down the taper with the dial indicator on it, and it's off about 1/1000th of an inch in the distance that we're going to be traveling with the ball end mill. The ball end mill, the depth of cut is 25 thousandths, so 1/1000th of an inch or so is not going to make a difference. Not sure how we're going to deal with this, because the one problem is, let's see here, I don't know what's going on here. Let me get my camera focused on that. So you can see here that it's a little bit off there. So let's see if it starts about 1/4 of an inch from this end. So if we go back the other way, we're headed towards 0. So, you know, it's about 1/1000th off. If we get back into this area, I did some touch-up cutting there, so it's not exactly right. The other problem is that if we could put a tailstock in here, you can see this is going low. Let's say it's by 1/1000th of an inch, but watch this. See? So I don't know where that play is in this taper here. It's just bending, or it's in the, I don't know where the play is, but I think that's probably the best we can do. There's no pressure on that little end mill, so it should just, you know, it's going to go this way too a little bit, but there's very little pressure at 25 thousandths depth to cut on a 3/32 end mill, so I'm not too worried about it. I think it'll look just fine. There's no way I can get a tailstock in here, so, and I'm sure, yeah, I don't know. Anyway, that's going to be where we're going to leave it right now. And so theoretically it's right. I could raise this another 1/1000th of an inch easily, so that might help. But I may try to do that and see if that makes a difference, if I can balance this out a little bit. Right now I got 206 thousandths under there. So with that, I'll bring you back when we get ready to cut the flutes, which will be later today, I think. With that, like I say, I'll bring you back. Okay, we're going to start cutting the flutes. I've set the vertical stop up at a 25,000 deep flute, and I got some stick out there with the cutter, which I don't like, and I probably don't need that. But I'm worried about the other end conflicting with the vice jaws. So we got to go around this thing 360 degrees. And we got to put in 12 flutes. So I'm going to, eventually I'll fast forward this in the video, but that said, we'll cut a couple of the flutes at normal speed. So this is my first attempt. So by the way, we got this set up perfectly, as you noticed in the previous comment on the video. I made a comment on the video. Obviously this isn't perfectly 3-degree taper. It's not perfect. It turns out it's 3 degrees, 4 minutes, and 20 seconds. And I had to add 5 thousandths to the height of the sign vise to accommodate that. So we figured all that out by just adding height to the sign vise little by little and then we worked backwards to see what the actual taper was. Anyway, that said, we're going to move ahead here and we're going to start cutting. And hopefully we're going the whole 25 thousandths deep on one pass. And we're running the mill. Maybe I'll turn the mill up, the speed of the mill up. We got the DRO set at 0, and I think it was, what was it? 1.95 thousandths. So that's where we'll just stop there. I'm watching the DRO, so hopefully I can get this. You can see we're getting a little bit close to the vice jaws, so we got to be really careful at the end so we don't go past our okay, we're there, and we're going to clear the vice jaws okay. Okay, there we are. We made one flute. Okay, that concludes the flutes. They look pretty good. You know, it's not perfect, but looks pretty good. Let me turn this light off here. See if the light compensation. If I can move the camera a little bit, maybe I can So that looks pretty good, actually. Let me clean that out. We'll run around it before we're going to take it out of the, we're going to take the forge off of the rotary table now. We're going to move it back over to the lathe. We're going to move it over to the little TIG lathe because that's what this forge off fits. So so let's run around it here. Take a look. I'll go the opposite. Let's go the same way we went here. Let's brush it a little bit more here. I think a little polish and it'll look pretty good. Those flutes are going to get painted individually. Okay, there we go. We're back to one again. Let's do something with this. Get this out of the way. So with that, I'm going to shut the camera off here. I'll bring you back when we move it over to the lathe. It'll only be a couple minutes. Over there, we're going to part it off, and we're going to clean up this end. Let's see what else. We're going to drill a hole all the way through it. And I think that's about it. We can do some polish work over there. We got to do some filing on these edges here. The top and bottom edges need to remain square, but these get a little chamfer. We'll file that on. I think this internal part is pretty much okay. We can run some 400 grit over it or something. Try to polish that up a little bit on the lathe. So that's where we're headed. So I'll shut the camera off now and I'll bring you back. Okay, we're back over to the lathe. It's only been 5 minutes. We just moved the forge jaw over here, and we checked the cross slide to make sure, or the cross slide to make sure we were square with the jaw before we parted this off. We put the parting blade in there. So we're going to part off that little end part there. And the next thing we're going to do is we're going to drill a hole all the way through this. I think 136 thousandths, where a piece of threaded rod goes through there to mount this to the base of the engine. So I don't know what we're going to use for a base. Maybe we'll have a wooden base. Who knows? I don't know. At this point, we're just worried about getting this test drive, I call it. But the sample piece done so we can get on with the brass. So I might mention too, there's a lot of ways to make this taper. You can just do that with the compound actually. The cut might not be as smooth, but we got a lot of flutes in there. So the compound might be a faster way. And also starting out with the right diameter, the right large diameter to do this. Saves a lot of work, but I just had that large piece of aluminum, so I went at it a little bit differently. Not sure which way I'll go at the brass, we'll see. But with that, we'll cut this off and get going here. So get this video concluded so we can post it up on YouTube. So there we go. Let's move the camera a little bit here. We can take a look at that. Maybe I have to get back out of the way. Zoom in on it a little bit. So there it is. Just a rough. So we need to polish it, chamfer some edges, so forth and so on. But there's a column. We got it done. Looks okay. All the procedures seem to be okay. So with that, we'll end this video, and we'll go ahead and chamfer some edges and fool around with this thing a little bit. But I think we can get on with the brass now. And so let's see. Maybe let me lower the camera down a little bit. Get a better view. So I don't think we're going to get any better than that. So with that, we'll call off and enjoy the video, and we'll see you on the next time around. I don't think we'll put any of the brass work on video unless we make some drastic changes to our procedure. Anyway, talk to you later. Thanks for watching. Bye-bye.